welcome to the second webinar of our SensorUp summer webinar series. And in this webinar series, the topic is building smart cities application with open geospatial IoT standards, that is SensorThings API. And today's second one, the topic is visualize your smart city and build a real-time smart city dashboard for SensorThings API. And I appreciate that you join us here. And then I know you have, everybody's busy, you have a lot of things to do. So I really appreciate that you choose to join this webinar and then to learn how to use SensorThings API and build smart city solutions. And then I appreciate that. Okay, so hopefully today I don't disappoint you. So first, about me, my name is Steve, and I'm associate professor in geomatics engineering, University of Calgary. I'm also a founder and CEO of SensorUp, and SensorUp sponsored today's webinar. It costs money to host webinar, and I'm also active in the OGC SensorThings API standard working group. I'm the editor and leading author for this API. I'm also a rapporteur for ITUT working group. It's called Question on IoT test specifications. A little bit about SensorUp. So SensorUp is a startup company and focusing on IoT and GIS. We're a leader in sensor web and IoT platforms, and we offer innovative and comprehensive SensorThings solutions. And well, we are the editor of the API, right? So I think we know what we're doing. And then we're a proud member of Eclipse and Open Geospatial Consortium. And in addition, we're also a member of S3 Emerging Business Partner and Microsoft BizSpark, and sponsored by Tectera. I have to thank for all their generosity to support us. So I think that it's a good thing to share some news with you guys every week. So update you what's going on. So first thing, finally, OGC adopts SensorThings API. Actually, it has been approved for a long time, since February 2016. But there's a lot of editorial efforts, and then also basically, it's last week we officially released the press release, and then so tell the world it has been published and available. So done deal now. Okay. And next one is we are working with a very nice group of sensor networks in Taiwan, and they have a grassroots effort. It's called LAS. And then so we decide we are going to set up a SensorThings for Taiwan's LAS system. It's a very large air quality monitoring network and very, very good data. Actually, I'm going to show you how the data look like. This is an application built on top of SensorThings, so allow you to see what's going on of the air quality over there in the past, currently, and maybe in the future. We'll show you the future, the prediction, like from the outputs from the models, right? So the last data actually allow us to have this very nice visualization and analytics, so you know what's going on. And then by using SensorThings API, that means you can really develop your application using open standards. So you can write once, but use many, many times, rather than every application they use different way, different API, this and that. So that's what we're going to do. Okay, great. So stay tuned. So next one is, in Calgary, we're going to deploy a large-scale sensor networks in Calgary, and then right now we have about 5 sensors, and then we expand to 10 this week, and then 50 by the end of summer. And so I would like to show you what's going on actually in my backyard. So if you look at here, it's very interesting. We have a hailstorm almost every day right now. It's a crazy place. But anyways, welcome to Calgary. So this is a hailstorm. As you can see here, the temperature drop more than 10 degrees in like a couple minutes, right? It's a hailstorm, like bam, a lot of ice falling from the sky. Makes sense. So the temperature drop and gradually comes back, okay? However, the air quality, the orange line is air quality. It just climbing up and to 22. 22 is not good, okay? It's not dangerous, but it's not good, definitely. It's quite interesting, and then dropped. I don't know what happened, okay? And last week from our sensor networks across the city, it shows the last week air quality wasn't very good. And then for me, it's just very interesting. But it shows an example. When you have a sensors in Internet of Things, you can get a lot of data from everywhere. And the data might not be high quality, but when you have more, you can really filter the bad ones, filter out the bad ones. You can get the good ones, right? That's the the spirit or the value of IoT. Lots of sensors, lots of them, and then you can get the big data, right? You can get the insight from them. And by the way, if you click on this link, you can get the data, exact readings from the chart I just showed you. And then if you don't like this kind of display, you can go here, and this give you the raw SensorThings API. And if you're a developer, this is what we'll be working with. And if you're a developer doing debugging or to test it, and this is add a display, and this is a SensorUp server implementation, and it give you a very, very nice way to visualize it. Okay, let's go back. And what will be covered today? We'll focus on visualize your smart city, so dashboard basically, how to visualize it, developing the code. So today we're going to show you how to develop a dashboard application and how to learn the SensorThings API from a coding perspective, right? Rather than only simply look at the UML diagrams or JSON responses. Let's look at some code in some real examples. And next week, we'll do analyze. So we want to help you to find some of the hidden SensorThings API functions, right, to do analysis. And then SensorThings API is not just a data API. It provides some query function, very powerful query function. That's very nice. And finally, the fourth webinar in 2 weeks, it'll be about build interoperable application, end-to-end solution, and put everything together. So please join us in the future as well. Okay, so today it's a learning outcomes. So first one, we'll review the SensorThings entities. So we start from a data model. Second, we'll create a chart for a data stream, and then with multiple requests. So that's the most naive solution. That's you send a request to get the data you want, and for this part, and send the other request for the other part. And if you are using the common or what I shouldn't say a lot, most of the IoT API out there, actually, this is what you need because it doesn't provide flexibility. I will show you what the flexibility means. It's called expand, right? And then you just need to send multiple requests here. Okay, and the next one, the third one, will show you how to create a chart with single request. So once you know what information you need from the API server, and then you can customize your query with one single request to get only the thing you need. It's very, very flexible and very, very efficient. So especially for web developers, right? Efficiency, and you don't want to spend time to write redundant codes, right? The fourth one, we create a map. So on top of the chart, at the background, as the background of the chart, and then show the location of the thing and data stream. And finally, create very, very simple dashboard, and then finally put everything together. And we'll show you 5 different applications, and source codes will be available on the GitHub, and then for you to play and try. Okay, again, I think every time we mention that, from your feedback, want to emphasize why are we going to use, why should you want to or should you have to build your IoT application with open standards. Okay, so let's use an example. What if you don't use a open standard, for example? So today is what most of people are doing right now, okay? And which is when you develop application, if you look at here, there's my cursor. Okay, look here, you want to have a chart, and you get one data stream from one system, okay? And you get a second data stream from the second system. The third is with the third system. So what does that mean? That means you need to write ad hoc proprietary code and to access the 3 different systems because they are using 3 different APIs. And you know what? They are very similar. All the IoT APIs, they look similar but different, okay? So that means you need to write n times different but similar codes, okay? And no guarantee for interoperability because some API they miss some information like observed properties. They might just don't have that information. They might not have a location information. It's very, very common for sensor networks. They don't have a location. They assume you know where's the location of the sensor, right? The target, they don't have that information. Or even unit of measurement, you'll be surprised how many systems, they don't even tell you the unit, okay? Or they hard code your unit in somewhere. So you need to write n times different but similar codes. Okay, it's fine, n times. Wait, how about version updates, right? We know you update your API, right? So how often do you update? Depends, right? You want them to update. So actually, that means you need to write n times m times of the codes. M, where m is the average number of updates, right? So you need to write not just the n times, you need to times m, which is the times of average number of updates. So this is crazy, yeah? So that means you need to write many, many times in order to keep your system working and work with different systems. Okay, if you today your application, you are pretty sure in the next a year or two, you only work with one system, that's it. And then great, actually, I think a proprietary and simple purpose-driven API might fit your application well. But if your application will grow to connect to different sensors, different networks, and then maybe you should use the open standard-based solution. It will be just better, faster, and cheaper. So if you build your IoT application with open standard, that means no matter how many systems you have, okay, you want to connect to, you write how many times? One time. How many times you can use? N times, or many, many different times, right? You can use, connect to N number of the service, right? Wait, how about version updates? When we use open standard, actually, it has been carefully considered and future-proof. So a lot of debates into this, and it's based on very solid model. So as a result, actually, the version update is not as frequent because we use a lot of time to prevent that to happen. Okay, it will happen. You want it to happen, right? You want it to be updated, but it will not be as frequent as the proprietary API because your API provider might decide, I'm gonna update tomorrow, and then so you shall update. Okay, you need to pay me the upgrade fee as well. Anyways, so this is what's happening right now. So to show you why you should use open standard. Okay, dive into the API. So today we'll use SensorUp's air quality monitoring system in Calgary as an example. So as you can see, there are 5 sensors right now, and this one is that's me. That's the sensor just out there in my backyard. And this is this link is the go to the endpoint for our API. Okay. And I'm pretty sure a lot of you will be following this, what we have been doing. So the endpoint is very important. Okay, so what do you need today? You need a text editor, the simplest one, okay, to open the HTML file and JavaScript. You need a modern browser, so Chrome in this case. We use Chrome as a modern browser. And then finally, the JSON viewer plugin. So you need the plugin. So every major browser, they have this plugin. You can view your JSON. So it's prettier instead of a whole bunch of just a text. We use JSON view in this webinar. Great. Important. So disclaimer. Today, our example, and we'll give you all source code. Okay. But by the way, we need to tell you, we are using highstock.js. It's a JavaScript library for chart. It's very, very popular. If it's not the most popular JavaScript charting library out there. However, by the way, it's open source as well and free for non-commercial users. However, it is not free for commercial users. So if you are using this, the Highstock for commercial users, and then you need to get the license from them. So just FYI, let you know, this is it's not from us, yeah, it's from them. Okay. Again, acknowledgement. Thank you very much, James. Today's source code is developed by James. And then, by the way, James and I were writing a book on SensorThings API and using IoT and smart cities as an example. So please stay tuned, and we will have a textbook or book for developers for you to learn the SensorThings API. Hopefully, very, very soon. We'll publish chapter by chapter. Okay, sounds good. Okay, today. So for any proper software project, you shall start from a data model, right? And for IoT projects, there's no exception. So start from data model. So in this case, a data model. What's a data model for our application today? So today's application is first start from a thing. So what is our thing? We're using a sensor. When we talk about sensor, it's like normally a thing, okay? Normally it's not a sensor per se, it's a sensor system. So like in a random example, like it's on my desk, okay? My desk full of sensors. Like a box, okay? A box, in this case, is a Ninja block. Anyways, and then a box, normally when you open it, it has a lot of sensors in it, okay? So that's a thing. So today our thing is Airbox. And then after error box, what sensors are we using? So sensor is the sensor to collect the data, right? To collect the observation. So in this case, we're developing, we use two different type of sensor. The first one is Plant Tower G3. That's the PM2.5 sensor, low cost. It costs about 25, 30 US dollars. So compared to other ones, it's very, very low cost. But in an IoT world, it's not that low. But anyways, just to let you know the cost. And the DH22. DH22 is the temperature and humidity. And DH22 is about $10. Okay, so that's a sensor. Oh, by the way, those are cost, okay? You can get it online, the cost you get online. So these are two sensors we use inside that air box. And then what observed property we are observing today? And we have three, so because DHT22 give you two observed property, yeah? So it's not one-to-one mapping. So particularly matter 2.5, this is from the Plant Tower, and then relative humidity and the air temperature from DHT22. Okay, these are the observed properties. So that's in the data model. So when you go to the SensorThings API, I'm going to show you, it will has the entities to describe that. We can call them metadata for this application. And where's the location? It's my backyard. And so that location is my backyard. And it's not a dot, actually. I use a polygon to show you that my backyard is the location, okay? So location is not just a map pin, yeah, map push pin. And then what's a feature of interest? Feature of interest means the target. So what, what's the purpose? What's the target I'm observing? In this case, the air in my backyard, that's the air. So that's a feature of interest. And finally, you will have a unit measurement in this data stream model. Okay, and then finally you have a data stream. So this is what we are covering here. So let me show you, for example. And for example, we go to observed properties. So we have three different observed properties, right? And then we can have a relative humidity, and this is a definition for relative humidity, right? So it's proper. And then we have sensors as well. So for example, two type of sensor, and then G3 and DH22. And if you go here, you click, you can get your sensor metadata, right? And it's a Chinese company, so it's it's in Chinese. Okay, but the numbers you can read it. Okay. What, you don't read Chinese? Okay. Anyways, sensors. So is this for example? I show the other. So how to navigate this API, right? Just a review. So this is ID. So sensors and ID, you get to see this sensor. Okay. If you are not familiar with this SensorThings API, please watch our webinar, the previous webinars, and we cover the basics. So what does how to use this API? But in a way, actually, if you just simply try our API, I think our API itself is human readable and very, very intuitive. So just try, how to use it. The basic. Okay. So that's reverse engineering, yeah? So today our first task is create a chart for a data stream. So let's look at chart first. So what kind of information we need from a data stream or from your IoT API? So what information do we need to create a chart? Where's my mouse? But anyways, so come back here, I got my mouse back. So first, you need a title for your chart, the title to show what is this chart, right? And then you need the y-axis label, so tell you, okay, so what's your y-axis? And for your, when you bounce over on this chart, the time series, you need a tooltip. In this case, the tooltip is the unit measurement. And finally, you need a time series. So these are the collection of observations, okay? So these are information you need to get from the API or SensorThings API. And then, here I'm going to show you, okay, so in order to get those information identified from a chart, where do we get them in the SensorThings API context? So what do we need from SensorThings? First one, title. So today we decide to use data stream's description. So with a description of data stream as a title chart, it makes sense, right? So as the chart for a data stream. So let's use the description for that as the chart. And next one is a time series. So what do we need from the time series? We need the result, so which is the value, and the time. In this case, with phenomenon time rather than result time. Okay, you can find definition for result time and phenomenon time in the specification. And third, we need a y-axis label. So that's a unit measurement, which is available as part of the property for data stream. Okay, and so in this case, the first one, data stream description, is one property from data stream, and UOM, unit of measurement, is from data stream as well. So that's one request. And in order to get the observations, you need to go for one level further down. So that's the second request, right? So naive solution, you need to send 2 requests to get this information. Next one. Okay. So this is just show you how to get that in a SensorThings URL pattern. So data streams ID / data stream give you the dash / description, give you the description. I guess I'll show you some example. So for example, this is data stream. You can / description. You get that description. Yeah. So you get that. And then data stream / observations. So, oh, by the way, observation here is a collection. So it's not just a property. So you need a separate request for this. So observations, you give it observations, right? And you can parse it to get your result in phenomenon time. Okay, finally, y-axis label. So you can get a unit of measurement. So data stream ID / unit of measurement. You get your unit of measurement. In this case, it's degree Celsius. Okay, so let's look at the code. So first, you need to send the request to the data stream. So here, first you get your URL, so the endpoint for data stream. So that's the endpoint. And then you send an example, okay, JSON, and we get the data stream back. Okay, so it's in your memory now. So once it's in your memory, so this is from a high chart, and then you just define it, data stream dot description. So you can get that, okay, and then to put it into high chart. Okay, it's in memory already, and then so because you get your whole data stream entity back, so you also have a unit measurement. And the other great thing about this is, no matter which SensorThings service you are dealing with, and then the data model is the same. So you get the data stream back, and then you just use the same pattern to get the information you need to manipulate the object in your memory. Okay, next one. So you need to send a second request to get a time series. So in this case, you get the observations. Okay, and this case, like James, because James knows the specification very, very well, so he follows the observation navigation link. So let me show you. So if you go to here, data stream, and you just follow the navigation link for your observation here. Okay, so that's your data stream. That's your observations. Okay, so you follow this link. Okay, it's a elegant way to do it. Okay, so after you follow a link, he adds some query parameters for this. So see, hopefully you can see right now what do I mean by we use the code example, allow you to understand SensorThings API. Okay, so you have that link, and then you can do some query. So in this case, you want to order by phenomenon time at the descending order. Okay, so because actually for every server, they might define the order in different ways, right? They might define the order in ID, okay, ascending or descending order, and they can be defined by phenomenon time or anything else, right? So in this case, just make sure what you get is order by time for time series, right? Order that by time. And top, that means how many you want to get. Okay, top 100 means get the top 100 observations in this phenomenon time order. Okay, so for example, I can say in this case, if I use top 1, so how many am I going to get in this return? 1. Okay, if I use top 2, I get 2, for example. Okay, easy. Okay, next one. So we get that, and then finally we need to get the y-axis label, and then sorry for here. Yeah, you see me point to the screen. It must be weird. Okay. Anyways, data stream, unit measurement, and symbol. Okay, so this is already in the memory, so you can just get it. Okay, from the previous request. So you can everything together. Okay, let me show you example now. Here are the example. The first one. So here's the example. So you get the description. You get your here. You get that, and here's the source code. So demo 1. So get that. So these are the things I show you, yeah? So you get the JSON, get the response. And then, oh, of course, here to initiate the chart. Oh, here's your data stream description, set your title, and then here is something from a high chart. You need to the observations in reverse chronological order, and then but the data must be sorted in ascending time. So some need to do this here, okay, before you put into the chart. And then after putting chart, here is you add the chart, add the data into the chart, okay? It's pretty simple, not just a few lines. Hopefully you see that very, very clearly and simple. Okay, next one. So what if we don't want to send redundant request, right? So I just want to send one request. So how to get all the required information with a single request? Here's the challenge here. So we have something very, very useful. You will love this function. It's called expand. It makes very, very flexible to use. So data stream ID expand observations. What does that mean? That means, let me show you an example. So today you get the data stream, right? So you get the entity for the data stream. It's RESTful, so that's the entity. And then, however, you want to get the next level returned in line. So that means here is the next level, so navigation link, and you can get link there, and here's the link. But I don't want it to, send another request. I want to be returned in line. So I can do expand observations here. So when you expand observation, that means here, this part will be returned as a JSON object rather than a link. This is very, very useful. Voila. So instead of a link, right now returns you the observations. Okay, sounds good? It's very, very useful. So as a result, actually you can get all the information you need with one request. So here we go. Here, it's the same thing like the previous example, but instead of you get your observation in the second request, we do expand. So you get all at once. And then, oh, yeah, so show you the example here. Demo 2. Here you go. Expansion observations. As a result, in here, you don't need to send another request. You already have the request already, right? So data stream dot observations. You already have it in your JSON. It's in your memory already, right? Easy. So you don't need to send a second request. It saves you some code, right? Okay. Great. So that's the second one. The third one, we're going to not only show the data stream, the chart, we want to show the location. Okay, so how to get the location from SensorThings API. So create a map showing the thin/location. So how to get things location? Okay, in this case, again, let's use expand. So data stream ID expand thin/locations. So that allow you to get your location. So let me show you. So here, and slash, oh no, expand. Okay, thin. And let me show you expand thin first. No, just let's go back step by step. This is our data stream. Right now, I want to expand thin. Okay, so make it, want to return the JSON object for that thin. Oh, sorry. So expand thin. Okay, what's gonna return? We are going to get the thin information, in line. However, what I need is location of that thin. So what can we do? So basically what we want to do is we want this guy to be returned within this guy, the thin. Okay, so we can do 2-level expand. It's very powerful, right? So bam, bam, 2 levels. Look at it. Isn't it beautiful? So you have your data stream, you have your thin, and then you have your locations. Okay, it's just one request. Very, very straightforward and difficult to make mistake. Okay. Oh, by the way, here we also need observations. So instead of expand only thin/locations, we also want observation to be returned in line. So this is what we can do, right? Expand observations. So in this case, which is want this to be expanded. returned inline as well as these things. So this shows you can expand multiple entities, right? Voila. So this gives you the observations, thin, and locations. Yeah. Hopefully you find it very, very useful. Okay. Next one. So here's a code. The first one, in this case, we use leaflet as our map. But if you use different JavaScript mapping library like ArcGIS JavaScript or open layers, and it's very, very similar. But we just use leaflet in this case. So first, you initiate your map like this. That's easy. That's what I do. We disable all the fun interactions to avoid accidental input here. And then we expand, we send a request, right? So in this request, we expand observations, things, and locations. And you get that, and then put it into the object. And okay, so here, data stream thing location. So you get your JSON response back, right? And then you can traverse it. So you get your data stream, the thing, and location, the first location. And then create a feature, and feature, which is, we use GeoJSON, so it's very, 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 very easy, right? Location, you just put them in as GeoJSON, and then you feature add to map. Voila, 3 lines of code, and then you can add. So no more, it's very, very easy, yeah? And I show you the example. No, this is the same thing. Okay, so this example, so that the map is a background, okay, and then we overlay the chart on top of it. And if you can see here, this is my backyard, my neighbor's backyard. My backyard is not that big, but this polygon is the location of my sensor. Okay, preserve some of my privacy. Yeah. Let me show you. Actually, I can show you the. Okay, yeah. So this is my backyard. Okay, so it's a polygon, not just a point. Yeah. So if your IoT API doesn't support the normal GIS geometries, right? You should choose a different one. But most of the IoT API out there, they treat everything as a dot. Anyways, we are the GIS expert, not them. Okay, next one. Create a simple dashboard. So in this case, actually, we're doing a dashboard. So normally what do we mean by dashboard? We mean like a page with a whole bunch of boxes, and each box delivers some different information to you, right? Could be a chart, could be a map, it could be the latest value. So in this case, just show you the very vanilla dashboard with 2 boxes. The first box shows the latest reading, and the second box shows you the previous reading, okay? And it's updating regularly. I wouldn't say in real time. Real time is a very, very difficult thing to do. Okay, so just show you what the end result is like this, right? And so, oh, you know this, right? This is the data stream description. And then you have 1 box. So what's this? Oh, what's this? This is the result. What's this? This is the unit of measurement, the symbol. What's this? This is the phenomenon time. So these are three things we need, right? And these are previous value. Okay, great. So what do we need? What information do we need? And then we need a result. We need a phenomenon time. And we only need the latest one. We don't need a whole bunch of 100, right? We just need the one. So in this case, what are we going to get? Data stream, observation, tab 1, select result, phenomenon time, and ID. Okay, why tab 1? Because we only want the latest one. And what is select? Let me show you what's select. Oops. Okay, so what is select? So like today, let's say we have data stream here, but for my application, I only need, I don't know why, but today I only feel like to have description. So this is how you get the return with only one, the only thing you select, okay? But maybe I need ID too, okay? Maybe I need unit measurement as well. So see, this is a way to save your bandwidth. So only get the information you need, yeah? And it's faster and save you response time as well. So let's select. So in this case, we only need result and phenomenon time. We don't need result time because we're not going to use it. So this is the API. How are we going to use it? So let's look at the code. With function here, get the latest result, and that's how we get it. So you get data stream, you follow that, observation and navigation link, you get your top one. It only wants result, phenomenon time, and your ID. Why do you need ID? Because you want to know when you have update, right? If is the latest one still the previous latest one, right? That means if there's no update, they have the same ID, observation ID. If there's update, and ID will be different, so you need that, okay? Okay, so that's the code here. And you set previous, set latest, and your latest observation is the one you get. Okay, very simple, like computer science or programming 101. So that's, I think I show you the example. Yeah. So this is the what we have achieved, and finally we combine everything together. Okay, so basically is put put these on top of the location, and you have chart as well. So look, this is the simple dashboard, right? So you have 3, 4 boxes, right? And you have other information overlay on top of it. See, so this is a simple vanilla tutorial. Vanilla means very plain, right? The simplest, no fancy libraries, because we want to reduce the code and complexity. But with feel free to add your own library, your own framework, and then put a bootstrap on it. It'll look much better, right? But we don't want to put too much code here today. So, but this is just a simple dashboard, with the purpose to show you what is a SensorThings API, how to use them. And then, so for example, in this case, we have all the source code we'll publish and share with you. Open source. Great. But there's one more thing. This become very popular in most of applications today. Okay. We found out actually a year ago, we developed a charting API, and then with the purpose, so to empower developers, you only need 1 or 2 lines of code, you can do a charting for SensorThings. And I think it's a great opportunity to show you that. So many of you don't want to write so many codes, right? You just need to a line or 2. And so you just a charting API that works. So today we announce we are going to release the SensorThings high chart and data table. So basically it's built on high chart and data table. Not very creative name, but it's very clear, literal. So it's the SensorThings chart based on high chart and the data table library. Okay, and it's free for non-commercial users. And if you want to use for commercial users, please contact us, right? I mentioned a couple of the restrictions imposed by HighChart as well. Okay, so it's free for you to use if you do on non-commercial users like LAS, right? That's great. So in order to display a thin's data streams, for example, a thin might have 3 different data streams, right? And then what kind of code you need? Actually, you can say this is just 1 line, 2 lines, I would say 2 lines, 3, okay, 3. 1, 2, 3. First, you initiate the object. You put your, the argument, the parameters. So this is the URL and your thing ID. Okay, and then you send the request, and then with success, you put into chart over there. Okay, that's a diff, and then you get this. Right, so instead of to write, okay, which data stream I need, and then how many requests I need to send, it handles for you, okay? Or for example, we handle this for you, right? The chart, title, if you want to do the title by yourself, you can do that, but this is a default, and you can put the unit of measurement, and the observed properties, everything is just there. 3 lines. But if you don't want a chart, you want a table. Voila, there's a table. So the only thing to do differently is this. Okay, I want a table instead of a chart. What if I want a gauge, something like a gauge for the dashboard, and then 1 line of code, you change that line, you're done. So speedometer, you can get that. If you want a gauge is solid gauge, you can get that. And if you want a D3 chart, and then you change to D3 chart, Voila. So this allow you to have write consistent interaction with your API, and also write the fewest line of code possible, right? And this is show you for example, you want data table instead of a chart. Voila, that's table, right? Let me show you more clearly. So that's a table you have, ID, object property, so on and so forth. And because it's using data table, you can even filter your readings, right? It's very useful. And if you want to display a data stream from T1 to T2, not just the latest one, and you just have one more line of code. So what's your readout start time and end time? Voila. Okay, so SensorThings HCDT HR data table will be available before August 18th, and we will publish the link with where you can get the slides and the YouTube channel, or just come to our website. So it will have library, SDK, developer documentation, interactive tutorials, and examples how to use them. Finally, if you think are good, actually this is some work we done a year ago. We just never share the work. Find it. Okay, I should say we were looking for the best opportunity to share with the world, but we're working on something much better. So to be announced soon. Okay, next week it will be analyzing your smart city and build sensor analytics with SensorThings API. Okay, so I hope you enjoyed. I appreciate your time to stay with us for such a long time. I mean, it's normally our webinar is 30 to 45 minutes. It's a long webinar, but nobody left. Okay, so I appreciate that. And then hopefully you'll join us next time. And then thank you very much. Bye.